Solving quadratics using the quadratic formula. This kind of is the conclusion of our solving quadratics section. We've talked about several different methods for solving quadratics. The first one was graphing, whether that be graphing it by hand or graphing it on the calculator. We also talked about factoring in a variety of ways. We went on to talk about the square root method. Then we went into completing the square. So our fourth and final topic is the quadratic formula. Now this is kind of the end-all, be-all. If you can't get it done any other way, this one always works. It doesn't matter what the equation looks like. It doesn't matter how it ends. It doesn't matter anything. This one will always give you solutions. And so let me just go ahead and show you the formula. The quadratic formula is probably one of the most famous ones, kind of up there with the Pythagorean theorem. Some of you learned this using Farajaka. I will not be singing that in this video. You'll have to go find some other teacher to teach you that. The quadratic formula: x equals negative b plus or minus b squared, the square root of b squared minus 4ac, all that over 2a. And so we're going to kind of explore that. I'm going to walk you through two different examples, and through those examples I'm going to show you step by step how to use the quadratic formula. Here's our first example. It's x squared minus 5x equals 4. The very first thing we have to do when we use the quadratic formula is to identify a, b, and c. Now in order for me to see that correctly, I need to put it in standard form, like you see here. By standard form, I mean it's all on one side and it's equal to 0. You most definitely want to have a positive x squared, although it's not a requirement. It's going to make things a lot easier. You don't have to worry about all the negatives, and especially with x squared out in front. Okay, so we're going to identify a, b, and c. In this case, it's easy to see. A is 1, b is negative 5, and c is negative 4. Be very careful to watch for negatives. It's really easy just to glance over and see the number and really not pay attention to the sign. If you miss the sign, you're going to miss the whole thing. It's going to make a big difference. Just a single sign will make a huge difference. Okay, so this third step, kind of introduce an idea here. We have this word called the discriminant. The discriminant is just the part underneath the radical. If you look up at the top, b squared minus 4ac, just this part here is what we call the discriminant. Because what's going to happen here is, depending on what this number is, if I have to take the square root of a number, well, that means I've got plus or minus a number. If it's 0, when I take the square root of 0, that's a 0. So there is no plus or minus part. So really we only have just one answer. And then the other side of it is what happens when my number underneath the radical is negative. Well, that means we're going to have an imaginary solution, or in fact, you'll have two solutions. So I've written down kind of what we look for in the discriminant. Okay, so in this green box you see it, the discriminant is positive. You're going to have two real zeros, or two real roots. Zeros and roots mean exactly the same thing as far as you're concerned. So sometimes I'll say roots, sometimes I'll say zeros. If it's 0, in other words, if the discriminant here, and you can see what we did, I plugged in our a, b, and c. We had negative 5 squared minus 4 times a, which was 1, times c, which was negative 4, and I work those out, and you get 25 minus negative, so that makes that plus 16. Be careful about when you have a negative, that's minus 4 right here, and if one of these is negative, it means you're going to be end up adding. So I have 25 plus 16 to give me 41. Because that says it's positive, then I'm going to have two real solutions, two real positive roots. Oh, I'm sorry, not positive. Two real roots, none of them will be imaginary. And you'll see that as we go along. Okay? We'll come back here. So, you only have a couple of different ideas that can happen. Positive, 2 real, 0, 1 real, negative, 2 imaginary. And the one that we're looking at right now You can see it over here. I've kind of worked it out for you. I went ahead and I plugged in my values. Negative b plus or minus b squared minus 4ac, all that. And the whole thing, be careful. A lot of common mistakes I've seen, they'll put the fraction, it's the 2a is just under the radical. That's incorrect. You see on the screen, it's the fraction goes all the way across. That negative b plus or minus part, that's on top of the fraction also. Don't think that it's separate. And so I'll go ahead and solve this. We already knew that was 41, so I just really took that and plugged it in here. I don't do it twice. Okay, if you already know what it is, we'll just plug it in. Well, in this case, I can't simplify this fraction. 5 plus or minus the square root of 41 over 2 it's not a very pretty number, but it's two real numbers. There are no i's involved in this problem. Okay, in fact, there are going to be two answers, so whenever you can't simplify, you leave your answer just like this. I definitely wouldn't attempt to do the decimal, although that's not incorrect, but you'll have to be careful. Sometimes I'll leave the instructions to be exact. Sometimes I'll have instructions to round to so many decimal places. If you want to round, and if I give you that option, by all means, please round, but this is the exact value. This is a much better answer than a decimal. Okay, so we can see that always check to see if you can simplify. Okay, always. Not always, or you can't always do it, but when you can, you always want to go ahead. Let's look at another example. This one is a little bit different. X squared minus 6x equals negative 10. This one's going to have some different kind of roots or different kind of zeros. So we go ahead and we identify our a, b, and our c, and we check out the discriminant. So I plug it in, negative 6 squared minus 4 times 1 times 10, which ends up giving us 36 minus 40, which ends up being, that is not negative 2. I'm doing this in my head already. That is negative 4. Sorry about that. What is the nature of my roots? And a lot of times you see this question asked, what's the nature of your roots? Well, the only thing it's asking you to answer is, well, do you have two positive, two imaginary, or just one real root? Okay. In this case, we definitely have a negative discriminant. That means I'm going to have two imaginary roots. If I'd had a positive number last time, I would have had two real roots, or if I have 0 there, I would have had one real root. In this case, it's negative, so we have two imaginary roots. Let's plug it in. Let me go ahead and get rid of this. We're going to plug it in, just like last time. We have 6 plus or minus the square root of negative 4 over 2. Now, be careful. I went ahead and simplified to get 6 plus or minus 2i because we have a negative under the radical. So whenever you have a negative, you've got to pull out that i. So the square root of 4, of course, is 2. Be careful. Check all three places to make sure that all three numbers are or have something in common, have a factor in common. In this case, they all share a factor of 2. When I divide out the 2, I'm left with 3 plus or minus i. And you can see here the solutions are 3 plus i and 3 minus i, which in this case both were imaginary. And as we go back to check our discriminant, it told us that there would be two imaginary roots, and in fact there were. This is exactly how you are to implement using the quadratic formula in solving quadratic equations. Be careful. Go back and check over the steps, all 4 steps, the discriminant values, make sure you know what those are, and make sure that you have this quadratic formula in your head. Most of you have it memorized already, but maybe you just need a little refresher. Go back, check over it. And if you have questions, please write them down and bring them with you to class.